Okay, good morning to everybody. Today we will learn actually how to solve ordinary differential equations or initial value problems by using Laplace transformation. So actually in previous lecture we have 3 lectures on Laplace transformation. On first lecture we have defined Laplace transformation and how to find Laplace transformation of some basic functions. And in second class, we learn the properties of Laplace transformation, and we have used different properties to solve Laplace to find the Laplace transformation of some basic functions. And in third class, we learn actually how to find inverse Laplace transformation. So today we'll learn actually how to solve ordinary differential equations and initial value problems by using Laplace transformation. Actually, we will try to solve this seven problem here. I designed 7 problem. Actually, this is some initial values are assigned to each differential equations. Some second order, third order differential equations are here. Now we'll try to solve these types of differential equation by using Laplace transformation. Remember it. Actually, to find the solution of differential equation by using Laplace transformation, this is the actually popular application of Laplace transform in solving differential equation. We can solve partial differential equation also. However, such application must satisfy the following 2 conditions. Actually, this application must be satisfied these 2 conditions. One is the variable s in the function of the solution, for example, x, y, z, t, another any variable must cover the range 0 to infinity. Because we must know from the definition of Laplace transformation, the integrand lies between 0 limit and infinite limit. It means that the solution, for example, ux or ut must also valid for the range of this. That means integrable. The given function will be integrable on this range. And the second condition will be all appropriate conditions for the differential equation must be available with the problem. Okay, so we must satisfy these 2 conditions. Now the solution procedure will be 3 types. The solution procedure will be apply the Laplace transformation on every term on the differential equation. Okay, the Laplace transform of every term in differential equation, the Laplace transform of every derivatives must satisfy derivatives result in the given condition, such as f of 0, first derivative of f of at t equals to 0, second derivative of f at t equals to 0, etc. We have to find the result as shown in that. Now, after applying the given values of the given conditions as required, step 2, this step 2 will be get an algebraic equation f of s defined in equation like this. We must know from the definition of Laplace transformation of f of t equals to 0 to infinity to the power minus st f of t dt. And this can be represented as the Laplace transformation of this f of s. Then we can obtain an expression for f of s. That means we have to find out the f of s from this step. Then the solution of the differential equation is the inverse of the Laplace transformation of f of s. Then we have to find out the inverse of f of s, which will be the solution of the differential equation. That means yt equals to inverse Laplace transformation f of s. So we have to solve using these 5 steps. Now we'll try to solve an example. Now for the second step, we have to find out, we have to use this properties, Laplace transform of derivative of f of t. Okay. So Laplace transformation of first derivative of f of t equals to s into Laplace transformation of f of t minus f of 0. That means we have to use this formula for first derivative of f of t. That means we have proved in our previous lecture using the definition of Laplace transformation. So Laplace transformation of first derivative of f of t, you can note down from your in your copy. Laplace transformation of f of f, first derivative of f of t will be s into Laplace transformation of f of t minus f of 0. Okay, note down this formula, and we can find the Laplace transformation of nth derivative of f of t using this. This is we must know about this derivative of Laplace transformation, nth derivative of Laplace transformation. And we have proved in our previous lecture, first derivative of a Laplace transformation, what was s into Laplace transformation of t minus f of 0. And second derivative will be this Laplace transformation of second derivative of f of t equals to s square Laplace transformation of t minus s into f of 0 minus first derivative of f of t at t equals to 0. Remember it. Similarly, third derivative will be what will be s cube Laplace transformation of t minus s square f of 0 minus s first derivative of 0 minus second derivative of 0. Remember it. If there are second derivative, then first derivative will be t equals to 0. And when it is third order derivatives, then second derivative will be of t will be 0 at t equals to 0. Okay. So fourth derivative of t, the Laplace transformation of fourth derivative will be s4 a Laplace transformation f of t minus s cube f of 0 minus s square f, first derivative of f of t at t equals to 0 minus s into second derivative of f of t at t equals to 0 minus third derivative of f of t at t equals to 0. Remember it. There is a sequence. So using this sequence, the nth derivative can be written as s to the power n. Okay. Here 4, 4. And here 3, and here will be what, n minus 1. And here another less than 1. That means n minus 2. And here n minus 3 dot dot. This will be what, n minus 1 at t equals to 0. Now all will be at t equals to 0 except first function, first Laplace transformation of f of t. First one is at t, all are 0. T equals to 0. Okay, t equals to 0. So you have to use these properties. That means Laplace transform of derivative of order n, we have to use these properties. First properties is this, and second one for nth derivative. Now we have to use this one to solve differential. Now actually solving ordinary differential equation like this. This is the second order differential equation whose right hand side is not 0. Then there will be assigned two initial conditions, because if the order is 2, if the order of differential equation is 2, then there will be two initial conditions. If there are 3, then there will be 3 initial conditions. Remember it. And where a, b and capital are constants. Capital A and capital B are also constants. Now the solution will be using these 3 steps we have discussed before. Laplace transform of a yt will be ys. First of all, we have to find out ys. Then solve for y in terms of s. Then take the inverse transformation. Okay. Just using this concept, we are trying to solve example of Laplace transformation. Find the solution of the differential equation. This y double differentiation of yt plus y equals to sine twice t, satisfying the initial conditions. Y equals to 0 at t equals to 0, and first derivative of y yt equals to 1 at t equals to 0. Remember it. This is the values of t within bracket. Now we're trying to solve this, actually applying Laplace transform to this equation, taking Laplace transform on both sides. Okay, both sides, Laplace transformation of y second derivative plus y equals to Laplace transformation of sine twice t. Now we must know Laplace transformation of second derivative of t. What was? S square. From your list, s square Laplace transformation of y minus s y 0 minus first derivative of y at t equals to 0. Okay, this is the formula of what? Formula of second derivative, Laplace transformation of second derivative of yt. Okay, second one formula. Then Laplace plus this plus Laplace transformation of y, actually using linear property, you must know. So, and this Laplace transform of sine twice t, what was? Sine at, formula what was? Actually Laplace transformation of sine at. Sine at, what was actually? Sine at divided by s square plus s square. Using this formula, sine twice t, what will be? 2 divided by s square plus twice square. Using this Laplace transform, here we get 2 divided by s square plus 2 square. 2 square means what actually? 4. So with now using the initial condition, y 0 equals to what? 0, and first derivative of y 0 equals to 1. Using this equation, this condition, so we can write this this formation. This equals to what was actually 1. Okay, and y 0 what? 0. So this become whole 0. So we get s square plus 1, just Laplace transformation of y, Laplace transformation of y will be common. Okay, this equals to 1 plus 2 divided by s square plus 4. Okay, 1 what was? This y dash 0 equals to what was? First derivative of y equals to 1. This is y minus 1. In right hand side it will be plus 1. Okay, now this is actually, this algebraic equation can be easily solved. Laplace transformation of y can be written as dividing by s square plus 1 on both sides. Okay, and taking LCM here, s square plus 4 will be LCM. So we get s square plus 6 in numerator. So Laplace transformation of y t equals to this. Okay, now using the method of last one, actually we can find out the inverse Laplace transformation of this. So inverse Laplace transformation of this equals to yt equals to 5 by sine of t minus 1 by 3 sine twice t. You must know how we can find the inverse Laplace transformation. First of all, we have to learn it, then we can find out. Just inverse Laplace transformation of this will be the give the solution of the differential equation. Now another example we can study here. Another one. So solve the following equation by Laplace transform. This is the first one I have shown you. This is the third order differential equation. This is why actually initial there will be 3 constants, and y dash equals to 1 at t equals to 0 and y equals to 1 at t equals to pi by 8. Here the given differential equation is this. Taking Laplace transform on both sides, we get this Laplace transformation of triple differentiation of yt minus 2 into Laplace transformation of second derivatives of yt plus 5 into first derivative of yt, Laplace transformation. And Laplace transformation of 0 equals to 0. Remember it. Taking Laplace transform on both sides of this equation, we can write. Now using third relation of derivatives, Laplace transformation of third derivatives of yt equals to what was this? S cube y minus s square y 0 minus s y first derivative of y at t equals to 0 and minus second derivative of y at t equals to 0. This is the formula of what? Third derivatives. Now second derivatives of y, Laplace transformation of second derivative of yt will be this. Okay, and Laplace transformation of first derivative will be first relation of derivatives. This equals to 0. Now using the y double dash second derivatives of y equals to k, we are just taking a constant k. Okay, because we are not given second derivative values. This is why this this s cube and this 2s square, okay, and 5s, just y this y bar, y bar, y bar will be common. Okay. So another constant, another one, first derivative equals to what? 1. So, and y equals to, at t equals to 0. First derivative of y0 will be, this will be 0. This will be 1. Okay, only s. This will be minus s. So minus s minus k plus 2. K comes from actually second derivative of yt at t equals to 0. Okay. So we can find the an algebraic form yt equals to what? This. Actually, this is the ys. Okay, Laplace transform. So k minus 2 plus s divided by s into s square minus twice s plus 5. Actually, this algebraic expression can be written as like this: k minus 2 divided by this, okay, and s divided by this. Then using partial fraction, we can find, we can take common here 5. Okay, so we can write this using what? Partial fraction method. Now this is the actually k minus 2 divided by 5 is constant, and this is the s function, and this is also s function. Now multiplying k minus 2 divided by 5 to this 2 term, we get this one. Okay. Now Laplace transformation of y, this is the actual Laplace transformation of y will be this and this. S minus 1 minus 1, what will be? S minus 1 divided by this and 1 divided by this. So 2 term there will be. So k plus 3 divided by 10 divided by 2 divided by this one, equation number 3. Now taking inverse Laplace transform on both sides of 3. What will be inverse Laplace transformation? 1 by s inverse transform, what? 1 by s, 1. 1 by s formula, what? Only 1. Okay. And k minus 2 divided by 5, this is the constant. And s minus 1 divided by s minus 1 whole square plus 2 whole square. That means e to the power t cos twice t. Formula will be this. E to the power t cos twice t formula. E to the power t cos twice t inverse transformation will be this. And k plus 3 divided by 10, this is the constant. And 2 divided by s minus 1 whole square plus a square. Formula what? E to the power t sin twice t. If there are constant 2, then it will be sin. And if there is variable s, then it will be cos. This is the inverse transform. Now putting y 5 by 8 equals to 1. This is the given condition. Yt equals to 1 at t equals to 5 by 8. So y 5 by 8 equals to 1. Using this initial condition, putting t equals to 5 by 8 on both sides. T equals to 5 by 8 on both sides. So y 5 by 8, what will be? 1. And k minus 2 divided by 5 and k minus 2 divided by 5. So e to the power 5 by 8, but e to the power 5 by 2 into 5 by 8, what will be? 5 by 4. Cos 5 by 4 means cos 45 degree. 45 degree means what? 1 by root over 2. K plus 3 by 10 e to the power 5 by 8 sin 2s t formula sin 45 degree after putting t equals to 5 by 8. So also 1 by root over 2. And from this relation, actually we can find k equals to 7. On putting the value of k on equation 4, we get the solution of the required differential equation. So first of all, we have to use the derivatives of Laplace transform. Then we have to find out the Laplace transform of this. That means ys. Okay. So this is the algebraic expression. Then using inverse Laplace transformation, we get yt. This is the yt, remember it. Then putting initial condition t equals to 5 by 8, we get this. And for solving k, we get k equals to 7. Just putting k equals to 7 in equation 4, we get the solution of the required solution for the differential equation. Now another example, using using Laplace transform, find the solution of the initial value problem. This is the second order differential equation, and y0 equals to 0 and first derivative of yt equals to 0 at t equals to 0. That means here t is the independent variable, y is the dependent variable, remember it. So, and it is ordinary differential equation. Now we have, this is the given differential equation, y second derivative of y t minus 4 into first derivative of yt plus 4y equals to 64 sine twice t. Now taking Laplace transformation on both sides. Okay, so you must know second derivative of yt, Laplace transformation of second derivative of yt is this second one in your copy, s square y Laplace transformation of y s into what, y of yt at t equals to 0 and first derivative of yt at t equals to 0. Similarly, first derivative formula of derivatives. Then for y, Laplace transformation. Y bar means what? Laplace transformation. Remember it. And Laplace transformation of sine 2st, what was? 2 divided by s square plus 2 square. Okay, from previous example, you must know 2 divided by s square plus a divided by s square plus s square formula sine at. Laplace transformation of sine at, what was? A divided by s square plus s square. That means sine 2st will be 2 divided by s square plus 4 square. This is the equation number 2. Now on putting the values of y0 and first derivative of yt at t equals to 0, just using these initial conditions, we get this s square into Laplace transformation of yt minus y dash 0 equals to what? 1. This is y1 and 4s Laplace transformation of yt plus 4 Laplace transformation of yt, and y0 equals to 0. This becomes 0 and this also 0. Okay, so we get this only. So common y bar means what? Laplace transformation of yt common, we get this. So this 1 in right hand side, 1 plus 128 divided by s square plus 4. So taking this can be written as y Laplace y bar can s square minus 4s plus 4 means what? S minus 2 whole square. Okay, so Laplace transformation of yt, that means y bar equals to 1 divided by this plus this divided by this. Okay, so using partial fraction method, we can write 1 divided by this 1, and this can be written as what? Using partial fraction method, 8 divided by s minus 2 and 16 divided by s minus 2 whole square and 8 as s square plus 4. Okay, using partial fraction method. So this is the actually Laplace transformation. Now we have to find out inverse Laplace transformation of yt. Okay, so this is the Laplace transformation of yt. So inverse Laplace transformation of will be yt, only yt. Yt equals to inverse Laplace transformation of this inverse this and this same term. So 16 and here 1, so 17 divided by s minus 2 whole square. So 4 terms become 3 terms. So inverse Laplace transformation of this, you must know inverse Laplace transformation of 1 by s minus 2 what? E to the power twice t, and 1 by s minus 2 whole square what? T into e to the power twice t. Okay, multiplied with t property, using the property multiplying by t of Laplace transformation. Similarly, s divided by s square plus 4 formula what? Cos twice t. Okay, s divided by s square plus twice square. So cos property. And this is the actually required solution of the given differential equation or initial value problems. Hello. Now we are trying to solve actually this differential equation. This is the second order differential equation. Y second derivative of yt minus 4 into first derivative of yt plus 4 into y equals to 64 sine twice t. Here t is the independent variable and y is the dependent variable. And this is the second order ordinary differential equations. And this is the initial value problem because in some initial conditions are assigned. Y equals to 0 at t equals to 0 and first derivative of y equals to yt equals to 1 at t equals to 0. Okay, now taking Laplace transform on both sides of this given differential equations, we get Laplace transformation of this equals to Laplace transformation of this one. Okay, now Laplace transformation of second derivatives of yt we must know from our properties of differentiation of Laplace transformation. S square Laplace transformation of yt minus s into y0 at t equals to yt equals to 0 at t equals to 0 and first derivative of y at t equals to 0 minus this is the 4 and first derivative of y Laplace transformation of first derivative of yt what was s into Laplace transformation of t minus first derivative of at t equals to 0 plus 4 into Laplace transformation of y what Laplace transformation of s. Okay, this is the t Laplace transformation t. So 64 into 2 divided by s square plus 4. Now s square into Laplace transformation of yt what was, this is the Laplace transformation of yt. Remember it, this is actually yt. Okay, Laplace transformation of yt. Here we yt. Okay, so at t equals to 0, Laplace transformation of yt can be written as y bar. Okay, y bar. We are writing Laplace transformation of yt as y bar. Then we can write like this. Okay, so Laplace transformation of yt y bar can be written as like this. Just y bar common, s square minus 4s plus 4 divided by it is equals to this. So Laplace transformation of yt can be written as y bar equals to s minus 2 whole square equals to 1 plus 128 divided by 5 s square plus 4. So Laplace transformation of yt can be written as s minus 2 whole square 1 divided by s minus 2 whole square plus 128 divided by s minus 2 whole square into s square plus 4. This is the equation number 1. Now we have to find the partial fraction of this. Okay, partial fraction of this. Now how we can partial fraction? I will try to find out the partial fraction of this one. Equation number 1. So this y bar, first take 128 divided by s minus 2 whole square into s square plus 4 equals to can be written as a divided by s minus 2 plus b divided by s minus 2 whole square plus c x cs, here s is the variable, cs divided by plus d divided by s square plus 4. Okay, 128 divided by s minus 2 whole square s square plus 4 can be written as a into s minus 2 s square plus 4 plus b into s square plus 4 and cs plus d into what will be s minus 2 whole square. This divided by what? S minus 2 whole square s square plus 4. Numerator, denominator will be cancelled. So we get only 128 equals to a into plus b into s minus 2 whole square. Now, if s equals to 2, then this becomes 0 and this also become 0. Okay, for s equals to 2, we get b equals to what from this relation? So 2 square and this will be 8b. 8 divided by 128, what will be? 8 divided by 128. 128 divided by 8, what will be? 4, 3, 2. 16. B equals to what will be? B equals to 16. Okay. B equals to 16. We can get easily B equals to 16. Now equating the coefficient of s square on both sides. Equating the coefficient of s square on both sides, we get a equals to what? Minus 8. Okay. Minus 8 and c equals to c equals to 1 minus 1 and d equals to 0. So we can form this partial fraction. So equation 1 can be written as, so from equation 1, Laplace transformation of yt equals to 1 divided by s minus 2 whole square plus 128 divided by, this can be written as minus 8 divided by s minus 2 plus 16 divided by s minus 2 whole square. 16 divided by s minus 2 whole square plus 8s s square plus 4. Actually, this 1 by s minus 2 whole square and this 16 by s minus 2 whole square can be written as 1 by s minus 2 whole square minus 8 1 by s minus 2 plus 17, 16 and 1, 17 s minus 2 whole square plus 8 s divided by s square plus 4. Okay. This is the equation number 2. This is the Laplace transformation of yt. Now we will find out the inverse Laplace transformation of this equation 2. So this can be written as inverse Laplace transformation of yt, y equals to inverse Laplace transformation of this one, minus 8 1 by s minus 2 plus 17 8s divided by s square plus 4. So this inverse Laplace transformation of 1 by s minus 2, what will be? E to the power at formula, minus 8 e to the power twice t. A means what? 2 here. So second inverse Laplace transformation will be multiplied with t. Laplace transformation multiplied with t, 17 t into e to the power twice t plus 8 into s divided by s square plus 4. Formula what will be? Cos twice t. Laplace transformation of cos twice t is this. So inverse will be what? Cos twice t. And this is the actually general solution of given differential equation. I hope everybody understand this maths. Actually, this is very easy for you. Understand this? And by partial fraction method, we get this constant. Putting these values of constant, we get this result. Okay, and y bar means what? Laplace transformation of yt. So equation number 2 gives the Laplace transformation, and this y gives inverse Laplace transformation. And this is actually procedure of solving differential equation. Now using Laplace transform, find the solution of the initial value problem. Same second order differential equation. Second derivatives of yt plus 9y equals to 6 into cos thrice t, and two given initial conditions. So we have actually this differential equation with initial conditions. Now taking Laplace transformation of equation 1, this is equation number 1. Okay, so taking Laplace transformation, double derivative of Laplace transformation of yt will be this. Okay, and 9 into Laplace transformation of yt will be y bar, and 6 into cos thrice t Laplace transformation of what? S divided by s square plus 3 square. Okay, equation number 2. Now putting the initial values y0 and first derivative of y at t equals to 0. Just putting here all these values, and y0 equals to what? 2. Okay, so this become twice s, and y bar 0 equals to only 0. So this becomes 0. Remember it. So we get only s square plus 9 and twice s plus 6s divided by s square plus 4. So y bar equals to, that means Laplace transformation of yt can be written as twice s divided by s square plus 9 plus 6s divided by s square plus 9 whole square. Okay. Now inverse Laplace transformation of y bar. Okay, inverse Laplace transformation of this plus inverse Laplace transformation of this one. So inverse Laplace transformation of this, what will be? 2 into cos thrice t, because Laplace transformation of cos thrice t will be s divided by s square plus 3 square. This is why inverse Laplace transformation of s divided by s square plus 9 is this. From chart you can check. Similarly, this can be written as, this is the derivative properties of Laplace transformation. In previous lecture we have discussed it. So inverse Laplace transformation of this can be written as actually derivative of minus 3 divided by s square plus 9, because this differentiation can be written as this. Okay, so actually using the properties of derivatives of Laplace transformation of yt is t into cos sin thrice t. This will be t into sin thrice t, and 2 into cos thrice t minus t into sin thrice t. This inverse Laplace transformation. From chart you can check. Now another one, using Laplace transformation, solve the following differential equation. Similarly, second order differential equations with given two initial conditions. Now taking Laplace transformation of this, actually here dependent variable is x and independent variable is time t. Okay, so taking Laplace transformation on both sides, we can Laplace transformation d square x by dt square plus 9 into Laplace transformation of x and Laplace transformation of cos twice t. Cos twice t Laplace transformation is this, and this is the second derivative formula for Laplace transformation of x. So x bar is the Laplace transformation. Okay, using same procedure and putting the initial conditions, we get this, and x bar is the Laplace transformation of xt. Xt is the function here, y equals to xt. So x bar equals to, we get x bar equals to this one. First derivative of x dash 0, first derivative of x dash 0 is not given here, so this is unknown for us. Now we are taking inverse Laplace transformation of this. So inverse Laplace transformation of xt, this of x Laplace transformation x bar will be xt. So 1 by 5 inverse Laplace transformation of this, 4 by 5 inverse Laplace transformation of this one, and inverse Laplace transformation of this. Now you must know the formula cos twice t. This is the cos thrice t, and this Laplace transformation can be written as like this using derivative properties. Okay, and this is the sine thrice t by 3. Now putting x pi by 2 equals to -1. That means if t equals to pi by 2, then x equals to what? Xt equals to what? -1. So xt equals to -1 when t equals to pi by 2. Just putting t equal to pi by 2 here. We get the first derivative of xt at t equals to 0. Okay, this will be 12 by 5. This is very important maths for you because this is the exceptional. We have to find out the value of xt. Now putting the value of x, first derivative of x0 in equation 3, just putting these values in this position, 12 by 5, we get the required solution of the differential equation. ভাষায় clear করবে. Another one, this is the also second order differential equations with right hand side not equal to 0. So taking as usual Laplace transform on both sides, we get this one, and second derivative of yt will be this, and first derivative of yt of the Laplace transformation is this, and Laplace transformation y is this y bar. Okay, y bar is the Laplace transformation of yt. So Laplace transformation e to the minus t, what will be? This is the basic function in first lecture, 1 by s plus 1. Okay, so just putting y bar equals to Laplace transformation of yt. Now putting y0 equals to -2 and y dash 0 equals to 8. First derivative of yt at t equals to 0 is 8 in equation 2. Just putting as usual. So we get y bar equals to what? This one. Okay. 6s divided by s plus 1 dividing by s plus 2 whole square, and twice s minus twice s. Here left hand side twice s, and in right hand side what will be? Minus twice s. So minus twice s divided by this s plus 2 whole square. So using partial fraction, we get this. Actually you can consider this a divided by s plus 1, okay, and b divided by s plus 2, okay, and cx plus and c divided by x plus 2 whole square. Okay, c divided by x plus 2 whole square. So a equals to 1 and b equals to -1 and c equals to -1. You get the values of partial fraction constant. So this expression, this fraction can be written as 3 partial fraction. So twice as divided by this can be written as s plus 2 minus 2. Okay, just for partial fraction. Now multiplying 6 with this 3 term, we get this one, and this become 2 term. Okay, 2 divided by s plus 2 divided by s plus 2 whole square will be 2 divided by s plus 2, and 4 minus 4 divided by this, and minus minus will be plus 4 divided by this. So s plus 2 whole square, s plus 2 whole square, same term, we can make it same term, and 2 divided by s plus 2, 6 divided by s plus 2 also same term. So we get only 3 terms from 5 terms. This is the equation number 3, because this is the inverse, this is the Laplace transformation of yt. Now taking inverse Laplace transformation of this from equation 3, we get 6 into inverse Laplace transformation of 1 by s plus 1, what will be? E to the power minus t. Similarly 1 by s plus 2 will be e to the power minus 2st. You can check the chart of Laplace transformation and inverse Laplace transformation of basic function. So 2 divided by s plus 2 whole square will be what? Multiplied with t property, t into e to the power minus 2st. So remember it, we have to follow the first lecture, second lecture, and third lecture. Then you can follow this lecture. Now solve the following differential equation by using, this is the third order differential equation. Here given conditions y0 at t equals to 0, y equals to 1, and first derivative of y with respect to t at t equals to 0, and second derivative equals to -2 at t equals to 0. So we are given the third order differential equation. This is equation number 1. Taking Laplace transform on both sides, we get this. Remember it, third derivatives of Laplace transformation of yt, what will be? This is the formula we have seen in first in earlier, this one, and second derivative will be this, and first derivative will be this formula. So Laplace transformation are denoted by y bar. Okay, and Laplace transformation of t square e to the power t, what will be? Multiplied with t to the power n formula, 2 divided by s minus 1 whole cube. Okay, you can check the chart. So putting the initial conditions, y0 equals to y, first derivative y, second derivative at t equals to 0. Okay, we get this one, just putting the values. And y bar is the Laplace transformation of yt. and this will be the in right hand side. So this means what? S minus 1 whole cube, remember it. So dividing by s minus 1 whole cube on both sides, we get this one. And this s minus 1 whole square and 1 s minus 1 whole cube means what? 1 by s minus 1. And this divided by, this can be written as s minus 1 plus 1 divided by s minus 1 whole cube to make partial fraction. Okay, we get 4 term from here because this term will give 2 terms. Now taking inverse on both sides, taking inverse Laplace transform on both sides, we get yt equals to, this is the yt and this is the t into yt and this is the t square into e to the power t minus and this will be 6 power, this is why t to the power 5 into e to the power t divided by 5 factorial, okay, 60. So we get the required solution is this. Similarly 49, this will be homework for you and I hope everybody can do using the similar process of solving differential equation. Now you can easily this integral equation, solve this integral equation taking Laplace transform on both sides. This is the first derivative, this is why first derivative formula for Laplace transformation, and 2 into Laplace transformation of y, and this Laplace transformation of this is the formula Laplace transformation divided by s. Okay, this is the integral properties of Laplace transformation, you can check from the previous lecture. So y by this can be written as y Laplace transformation of y t divided by s, and sin t formula Laplace transformation of sin t what? 1 divided by s square plus 1. Now putting the initial condition y0 equals to 1 because this is the first order differential integral equation. So just putting y0 equals to 1, we get Laplace transformation of y bar equals to this one. Now you have to use partial fraction. Partial fraction. How we can use partial fraction? A divided by s plus 1 and b divided by s plus 1 whole square and c cs plus d divided by this. Okay, so first of all you have to learn how to make this partial fraction. Okay, then taking inverse on both sides, we get easily this. Now solution of simultaneous differential equation by Laplace transformation. Simultaneous is system of differential equations. Suppose this is the first order x is the independent variable and t is the dependent variable. So this is the xt function. Okay, and this is the another differential equation. So this is two differential equation make the system of differential equation. The first one can be written as x bar plus y equals to 0 and this y bar minus x equals to 0. Now taking Laplace transform on both sides of 1 and 2, we get first derivative of xt will be what? As x s into Laplace transformation of xt minus x0 at t equals to 0, y Laplace transformation of y. Similarly y bar will be what? S into Laplace transformation of y minus y0. So now substituting the values of x0 and y0 in equation 3 and 4. Okay, x0 and y0 in equation using the initial condition, we get this two equation. From 3 we get this one after putting values, and from 4 we get this one. Now solving 5 and 6 for x bar and y bar, actually by cross multiplication, you can use cross multiplication method or substitution method. Okay, putting y bar equals to this, then here we get x bar values, and putting x bar values from equation 1, from equation 5 we get y bar values. The solving for x bar and y bar. X bar means Laplace transformation of xt and y bar means what? Laplace transformation of yt, remember it. So inverse Laplace transformation of xt will be what? X equals to inverse Laplace transformation of this and inverse Laplace transformation of y t will be y, only yt. Laplace transformation, very easy. Okay, just using formula. Okay, similarly, so we can solve this simultaneous equation system of differential equations by using Laplace transformation. And this is the first 3 into dx by dt, y minus y equals to twice t. This is the function of xt, and this is the function of xt and yt. So this is the given equation, can be written as like this. This is equation number 1 and 2. Now taking Laplace transformation of on both sides of equation 1, we get 3 into Laplace transformation of x bar minus Laplace transformation of y equals to Laplace transformation of twice t, can be written as this. And first derivative formula will be this. Y bar means Laplace transformation of yt. So we can get this. Again, like taking Laplace transformation of for the both sides of equation 2, we get this one. Okay, Laplace transformation of 0 will be 0. Same procedure, we can get this equation number 4. So from equation 3 and 4, multiplying equation 4 by 3, we get this one, number 5. Now subtracting 3 from 5, subtracting 3 from 5, we get this y bar equals to this. Okay, now taking inverse Laplace transformation of y, this we get original yt, and this is the one result. Now substituting these values y bar in equation 3, then we get x bar values. Okay, x bar values. Now just taking x bar, and this is the 1 by s cube, 1 by plus 1 by 2 s square minus, from this we can write this 1 by s minus 2 by 3 minus partial fraction. By using partial fraction method, we get this. So taking inverse Laplace transform on both sides, x, this will be xt. Okay, so now from equation 6 and 7, we can take and together with the complete solution. Very easy for you. I hope you can practice it at home. So this is actually how to solve ordinary differential equations or boundary initial value problem by Laplace transformation. We have solved these 7 problems, and we have solved also 2 systems of differential equations. If you do practice and follow the previous 3 lectures, I hope you can do this. Okay, first of all, you have to follow the lectures. Thanks to everybody. In next class, we will discuss the application of Laplace transformation actually in engineering. That means in electric circuits, how we can solve the problem of engineering, electrical engineering, civil engineering, etc. problem we will discuss in our next lecture. Thanks to everybody.